Chapter 6 takes us into exponential functions. Okay. Eventually we'll be talking about logarithms, but right now we're starting with exponential functions. Logarithms are probably all brand new, but it'll be something different. So exponential functions are the focus. And so today we're just talking about some key features of these exponential functions. What do they look like on a graph? And how do we use them within problems? Okay. You may have talked about exponential growth and decay in a science class somewhere along the line, or maybe another math class, but that goes along with today's lesson as well. So, some information here. Exponential functions are equations of the basic form y equals a times b to the x. Notice, where is my x value? It is in the exponent. And that's what makes it an exponential function, is your variable is in the exponent. And then your base is a number. So your base is a number, variable in the exponent, we're talking exponential function. A little bit of information. A, the number before the exponent piece. A is your initial value. So when we talk about word problems, that's your initial value. When we talk about on a graph, it's going to be your y-intercept. So wherever x value is 0, that a value is going to represent your y-intercept. B is your rate of change. I could have also probably written it's your base, okay, because I also call it the base. Your rate of change, when we go to word problems, this is where your percent's going to come into play, as into how much growth and decay there is. In the backside, we'll talk more about growth and decay, but if your b value is a number bigger than 1, this is going to be a growth function. For example, this is an example of what a exponential growth function would look like. If your b value is less than 1, or between 0 and 1, so like a decimal between 0 and 1, then it's going to be exponential decay. And if it was exponential decay, this graph would start high and be heading low. Okay? So with this graph, realize, I did this in Desmos and I didn't have an easy way to look at this. This graph is, first of all, running along the x-axis here before it goes exponentially up. Okay? Going quicker and quicker up. A couple of things. Domain. What do I mean about domain? Domain are my x values. And does it make sense if we say the domain of a basic exponential function is all real numbers?
Yep.
It's going infinitely left, yes. And as it's going up, it's going infinitely right. So your domain on all of these will always be all real numbers. If you heard that and you can stick that in your memory, there's some free answers on homework. Domain is always all real numbers. I haven't run into a single exponential function that's not all real numbers. So, key to note there. Why did I put these in this order? Okay. The asymptote. Okay. You'll also be asked about asymptotes. We've talked about asymptotes, I believe, but asymptotes being invisible lines that our graph runs alongside, right? Well, as I talked about this graph running alongside the x-axis, okay, this graph, as it goes off to the left, it's going to run closer and closer along the x-axis, but never touching and never crossing. Okay, so when we draw these, you want to make sure that you're going alongside that asymptote, never crossing, never touching. So the asymptote on a basic exponential function is, the equation for it is y equals 0, which is the equation for the x-axis. Because horizontal asymptotes are y equals a number. Where does it cross the y-axis? Well, this one would cross at y equals 0. Okay. You don't run into any vertical asymptotes, just horizontal asymptotes. Now, when we start talking about our graph possibly shifting up or shifting down, what's that asymptote going to do? It's going to shift up with the graph or shift down with the graph. Okay? So we'll talk about that a little bit too. And then we talk about range. If my asymptote is the x-axis, my graph is never crossing, never touching, where are all of my y values? My y values are all going to be up, right? So they're all going to be greater than 0. And so that's why you'll see here the range is y is greater than 0. Now, to go alongside of that, if my graph shifts down or shifts up, is that range going to change slightly? Yeah. Okay. If my graph moves up 2, then my range is going to be y greater than 2 instead of y greater than 0. And we'll talk about a little bit of this when we graph some of these. Okay? So, those are some basics. That's kind of your chart of information there. We're going to start off by doing some basic graphs of how to graph these. And we're going to answer some questions about key features, which is going to include things like domain and range, asymptote, I forget what else, intercepts, and end behavior. All of which are things we've talked about. We're just going to bring them all into here. And I will say, you have some homework questions that are 5 parts. They are 5 parts because it says, what's the domain? What's the range? What's the intercepts? What's the asymptote? What's the end behavior? Okay? So, you're going to see these type of things. Now, y equals 2 to the x. I want to start by, let's practice graphing.
Yay.
I've told you a little bit about what the graph looks like. I've shown you a picture. How are we going to graph y equals 2 to the x? Well, I'm giving you a hint here. If you don't know how to graph it, if you don't know exactly what it looks like, XY chart?
Yep.
Thoughts about some x values?
0, 0.
Well,
4, 2. 9, 3.
Okay, you guys are throwing out, okay. Let's talk about some x values only here. You guys are throwing out some square root pairs.
0.
This isn't square root.
0,
Yeah.
1, 2, 3, 4.
0, 3, 6, 9.
Oh, 0, 1, 2, and then negative 1.
negative 1.
I love how I can plop that 0 in the middle, then you guys immediately know, oh, okay, she wants me to say negatives now. Okay. Now, this is a graph. You do need to usually include some negatives. Otherwise, we're not going to get the full picture of the graph. Okay. I'm going to try and make this easy on us. So we're going to start at the bottom of this XY chart and work our way up. So we don't have to start with the negatives. Okay. So this is the graph we're doing is y equals 2 to the x. So when we put in 2, this is going to be 2 to the second. And what is 2 to the second?
4.
4. Are we good there? Because we're putting it in for the
2.
x value, right?
X.
So what about when x is 1?
2, 1.
Put 1 in place of x. And what is 2 to the first?
2.
2. Okay? When x is 0, my question becomes, what is 2 to the 0?
4.
1.
Anything raised to 0 power is always
0.
1.
1.
And I will say, the calculator will verify that. Okay? So if you ever forget, grab the calculator and punch 2 to the 0 into your calculator, and it's going to say it's 1. So if you're questioning yourself.
Why?
Okay. Now, 2 to the negative 1. Okay.
Negative
2.
How do we deal with negative exponents?
Oh,
I
I
if
just
it's,
wrote
a,
it in
if it's
pen.
an
so
even
it
number,
never
then it's a positive.
Negative exponents.
If it's an even number, it's positive.
How do we make a negative exponent positive?
If that's 2. Over 1.
You move it to the denominator,
I got that right.
and so this is going to become 1 over 2 to the first.
Why?
And what is 2 to the first?
2.
2. So this is 1/2.
This is like an easy problem.
I got that.
And your calculator told you probably 0.5. Is that equivalent?
Yeah.
Yes. Okay. So there is some checking now. And here's what I'll say. Use the calculators. Yes, that's good. Use it to help you along. But there is also importance in remembering the negative exponent. Okay? So, now, 2 to the negative 2.
-1 or 1 or 0.
What?
Ooh, my lord.
Oh, is it 1/4?
Why?
Because I said. Because the other one's 1/2.
Okay. How do you deal with a negative exponent?
Whoa.
You move it to the denominator, and then it's going to be 1/2 to the second,
So it's 4.
which is 1/4.
Look at that.
Because this is something you're going to have to be able to work with negative exponents in this chapter. Okay.
No, you're 2.
And here's the deal, guys. This was example 1. So yes, I was kind of writing out my thought process over here. I'm not saying you have to write that out. Okay? And obviously some of you probably did. However, if I don't write those negative exponents out on the first time through, or even the second, third, or fourth time through, I'm going to lose some of you. Okay? So, let's graph this now. Ordered pair, -2, 1/4.
I got you.
Where do I go?
You go left 2.
Uh-huh.
Up 1/4.
Of 1/4 of a
Yeah.
box, which is very, very tiny, isn't it?
I think it's really good.
So left 2, and just, you're going 1/4 of a box up. So
I got it.
you're just slightly above the x-axis.
Yes.
Where's -1, 1/2?
Left 1, a half a box.
Left 1, up half a box. If I go left 1 up half a box, here's the deal. Technically, it's a teeny bit higher than the previous one, yes?
Yes.
Correct.
But it's still not a full box up.
Correct.
And it's still technically not touching the x-axis.
Correct.
It would-
I know, easier said than done.
It would never touch, right?
Yes, correct. Okay, 0, 1. Left, right, 0, and
That's
Up 1.
up 1. 1, 2.
Over 1. Up 2.
Over 1, up 2. 2, 4.
Oh.
Okay. When you draw your graph, please take care to keep it above the x-axis.
Oh.
Okay? So when I draw this,
I think got it wrong.
I get it.
I think got
It's
right.
thin.
now, technicality here. So technically, this graph as it goes left never crosses, never touches the x-axis. Well, it's kind of hard to draw that without touching, but here's the deal. What I did there, that's acceptable in my brain. Yeah, it kind of looks like it's touching, but did I make every effort to not cross the x-axis?
Yeah.
Yes.
And that's what I need you guys to do.
Good job.
So when it comes quiz time, a test time, you draw that actively below the x-axis, I'm going to take a point on. Okay? Okay. Now, we have some questions to answer.
Yep. Dude, I love this class. You do?
Okay.
Jeez.
Domain. Easiest question I'm going to ask all day. Domain.
All real numbers. All real numbers.
Okay.
Yes. All real numbers.
Domain is all real numbers. My graph's going infinitely left, infinitely right.
Just leave them on the back side. Always there.
Okay. Range.
Negative infinity and positive infinity.
No.
No.
Oh.
Why?
Okay.
Negative.
How low does my graph go? Remember, range is up or down.
Doesn't touch the x-axis.
1/4.
Okay. My range does not go below
1/4.
the x-axis. Okay. It does not go below the x-axis. How high does it go?
Infinite.
Infinitely up.
Yep.
Okay. So this graph, unless your graphs are translated up or down, my range is going to be y greater than 0.
Yep.
Now, I believe the answer key uses the greater than sign as opposed to like 0 to infinity. Okay, 0 to infinity would be technically correct. Now, because I don't want you to be thrown by the notation of what you're going to see, they're going to use braces and say y such that y is greater than 0.
And is that how I have to answer?
Okay, now, listen,
What does that mean?
listen. So, you're not going to have to type in this whole notation. Me, personally, as a teacher, I'm pretty lax about this in that I am happy with you being able to write y greater than 0. I'm fine with that. Now, in a Savas, I believe you have to pick from, it's like a multiple choice, and you have to pick, like they're already going to have this all filled in. You just have to fill in a number and pick. Am I using the equal, the greater than, the less than?
Mm-hmm.
So I just want you to be familiar with this notation. Focus in on y greater than 0. But this is properly read as y such that y is greater than 0. Okay? Again, I don't want you guys to walk and complain. What is this stuff in this homework?
We learned about
What? Double tough.
Okay, the next question,
Next.
ask about intercepts. Now, what do I mean about intercepts?
I got the y-intercept when it crosses the y-axis.
Okay, so we talk about intercepts. Listen, we're looking for where the graph is crossing the x-axis
But it
or
doesn't. It
y-axis.
doesn't.
In this case, we're never touching the x-axis, so the only intercept we're going to have is the y-intercept.
We don't have to write anything for x if it doesn't.
I don't think so. Where does my graph cross
1.
the y-axis?
Y equals 1.
Y equals 1? Now, I believe you just get to type that number in, if I recall correctly. Okay? As an ordered pair, you would say 0, 1, but I don't think they asked for as an ordered pair. I think they just had 1. Okay. Told you, 5-part question.
Hey, we still got in behavior after this.
Okay. Asymptotes. Asymptotes are those essentially invisible lines that my graph never crosses, never touches.
Why is there a P in that?
Okay. Anyways, where's my graph never crossing, never touching?
X.
Okay. X-axis. Now, they won't want you to say x-axis. They'll want to know the equation for the line. And that's always true when you're asked about asymptotes.
X equals.
I'm totally fine with you answering out loud x-axis, but what is the name of that equation?
X equals 0.
Not x equals 0.
Y equals 0.
Okay. Because it's a horizontal line that crosses the y-axis at 0.
I got it.
Okay. If it's a vertical line, it's x equals a number because it crosses the x-axis at a certain number. But this is where all y values are 0.
Yeah.
Okay. Now, in behavior, we've talked about this year. I know we have. I don't remember what unit it was in. We probably talked about last time we talked about asymptotes. And when we did this, we talked about in behavior, it's what is my graph doing on the two ends. So what is my graph doing as it goes off to the left? Or as x approaches negative infinity, what y value is my graph approaching? And then as x approaches positive infinity, so as my graph goes off to the right, what y value is my graph approaching? Okay? So, we're going to have two answers within behavior. We're going to have an answer based off of when x approaches negative infinity, what is y approaching? And when x approaches positive infinity, what is y approaching? So those are the two things we're going to fill in. Okay, in behaviors always does two pieces. As x approaches negative infinity. So, as x approaches negative infinity, as my graph goes to the left, what y value am I getting closer and closer to?
Infinity.
Negative.
Oh.
What y value am I getting closer and closer to?
Zero.
0. Because if you're going to tell me negative infinity, you're going to say my graph is going infinitely down.
Is it?
My graph isn't going infinitely down because it's running alongside an asymptote, yes? And that asymptote is 0, has a y value of 0, right? So your in behavior, in this case, on the left, is y is approaching 0. Now, if your asymptote is anything other than 0, that value will change, okay?
It'll touch the 0.
It doesn't, no, it won't touch. In behavior is not necessarily touching, it's what is it getting closer and closer to. So it's
getting
approaching.
Closer and closer. It won't touch it.
Nope. It's an asymptote. It won't ever touch it.
Oh, you got thermostat?
Now, x greater than 0, or x approaching positive infinity. As my graph is going to the right, what y value is it approaching?
I don't want
0.
So as my graph is going off to the right, it's going where?
Infinity.
Up and up and up, which is
Infinity.
positive infinity. Gosh. There we go. So these pieces right here are my in behavior. Okay? You will be asked about both, and you will have to fill both pieces in. Okay? They'll probably already have it set up, and you're just filling in pretty much the 0 and infinity that we filled in. If my graph is flipped and going the other way, then those answers might be reversed. Okay. Questions I can answer on this? Questions that you want to ask?
Why does it never touch the 0?
Because Gallon.
It's getting closer and closer and closer.
So you're dividing something by 2.
Nope. If you continue to put,
That's good.
take your calculator and try putting in smaller and smaller numbers. So if we say 2 to the negative 10, 2 to the negative 15, 2 to the negative 100, 2 to the negative 200, 2 to the negative 1,000, your answers will always be 0 point something. They will never be negative, and they will never be as far as 0. Okay? Yes?
Is the end behavior essentially ordered pair?
It's not an ordered pair because they'll always have the x and the y approaches, so the arrow part. So, and you're going to be filling in basically those two pieces. Okay? As I said, I know we tested on this at some point. I don't remember exactly what unit it was, but. Okay. Now, this is a basic graph. This was just 2 to the x. No extra bells or whistles thrown in.
Oh my goodness.
So, time to throw in some extra pieces, right?
Like fraction.
Look at this one.
Okay. So, B. We're changing a little bit up. First of all, we're throwing in a fraction base, which changes the direction our graph goes. And then on top of it, we're throwing in that 5 out front. Now, if I jump ahead a little bit, what is, well, there's a couple different things we can talk about here, but what could you view that 5 as if it's multiplying by the function out front?
5/1.
What's it going to do to the graph? Stretch it?
Vertical stretch.
Vertical stretch?
Yes.
So my 5/1.
Okay. So, just realize that. Now, also if you look, 5 also, and we'll prove this here in a moment, if I go back to this first page real quick, this 5 kind of fits into the A category. Listen, please. And in the A category, it's the initial value or the y-intercept. So my y-intercept is going to be different. Settle. Okay. My recommendation on all of these is going to be that we start with some XY values. So XY values I'm going to pick here again.
-2, -1, 0, 1.
Writing in pen.
Okay. Now, We're going to plug some values in.
Stack.
I don't know if I should tell you to start with negatives or positives here,
Negative. I will start
but
negative.
Hi.
yes,
Could we start with those numbers every time?
for the most part, yes. I'd say, and actually, all the way I'm teaching everything, I'm going to always start with those numbers.
So on like
So.
the test, we'll get partial credit for that.
I can't think that hard of that head. This is day 1 of this unit, so.
We,
Okay, so,
You're on chapter 2.
okay guys, work with me here. 5 times 1/2 to the negative second. Now, okay, negative exponent. Earlier, the negative exponent was just on a single number, and it told me to take it to the denominator. Well, this time, we already have a fraction. We already have a denominator. A negative exponent, basically earlier it told me to flip the problem, essentially. The negative exponent tells me to flip the fraction. So what this problem is going to become is 5. Instead of 1 over 2, it's going to be 2 over 1 to the positive second. Now, at this point, what's 2 over 1?
So one,
2. What's 2 squared? 4 times 5.
20.
There you go.
I didn't get that.
Now, can the calculator help to an extent on these?
Yes.
Yes, it can, okay? However, there is importance in being able to do this with your brain as well. Okay, let's try negative 1. 5 times 1/2 to the negative 1. How do I deal with the negative exponent?
Flip it.
Flip it.
Flip it. So this is going to become 5,
2 over 1.
2 over 1 to the positive 1. 2 over 1 is 2. 2 to the first is
2.
2 times 5? 10.
5 times.
Okay? Now, 5 times 1/2 to the 0. First of all, remember,
Oh, I know.
that 0 is only on the 1/2, right? So what is anything raised to the 0 power?
1.
One.
No.
1. So this problem becomes 5 times 1. And 5 times 1 is 5. Okay? 5 times 1/2 to the first.
5 over 2.
It's 5 times 1/2. You can say 5 over 2, or if you're a decimal person, half of 5 is 2.5. I'm not picky about whether you express that as a 2.5 or a 5/2. You do have to know how to graph it, though. Okay? And 5 times 1/2 to the second. Now, 1/2 to the second. That means 1/2 times 1/2. What's 1/2 times 1/2? Or in other words, 1 times 1 over 2 times 2. 1 over 4. So now it becomes 5 times a 4th, which you could write as 5/4, or you could write as 1.25.
Yes. Woo! Decimals. Let's go.
Okay.
But how?
Yeah, how am I going to grab 20?
Okay, we're going to guesstimate on 20. It's
That's going to go.
It's hard for me to get
exponential.
exponential functions that stay on the graph, I will tell you, because there's always that one big number that just skyrockets up off the graph. So, okay, so negative 220. What's that tell me to do?
Go left 2, up 1.
Left 2, and I can't even really estimate up 20. It's going to be up on the wall for me. Okay?
It's going to be in the graph there.
Now, it's for you guys, it's going to be up on the other graph. You don't even have to put a dot up there if you don't want to.
I'm not.
Okay?
I did.
Now, negative 110. Left 1, up 10.
Oh no, that's
I
on
forgot
the
about that one.
Okay?
Ooh, right out the window.
And here's the deal. If you have multiple big numbers going off the graph, then you probably need to estimate some dots. One big number going off the graph, not a big deal. 0, 5. Left to right, 0 up 5. 1, 5 halves, or better said, 1, 2.5. So right 1 up 2.5 boxes. Right 2 up 1.25. Okay. Draw your picture out. As you draw this, a couple of things to keep in mind. First of all, as you draw up vertically, it should be going very steep at this point, yes? Because the next point up, the next point over is 10 boxes up. So it should be very steep. As we go off to the right, guess what's happening? My graph is never crossing, never touching the x-axis. And I know it's always the x-axis unless I move my graph up or down. Okay? Okay, domain.
All real numbers.
All real numbers all day long.
all day long. Oh, I spelled the name. Oh no.
Range. So domain is how far left to right my graph goes. Range is how far
Up and down.
up and down. How far down is it going?
0 hour. Oh, wait.
Lowest it goes is right almost to 0, essentially, yes?
Yeah.
How high is it going?
Infinite.
Infinity. So how do I write that?
Y is such that greater than. Good job.
Okay. Y such that y greater than 0. Again, what am I concerned about?
Y greater than 0.
I'm happy with y greater than 0. I'm just trying to show you official notation so it doesn't totally send you for a loop when you see it in homework and stuff. Okay? And that y greater than 0 is going to stay there unless your graph shifts up or down. What's the next part?
Intercept.
Intercepts. What do we have in the way of intercepts?
Y. Y, just Y dot.
Just the y-intercept again. What is my y-intercept?
5.
It's a 5 this time. Why is it 5? Because this value out here was a 5. Okay?
Oh, look at that.
So y-intercept of 5. You had to do an ordered pair. It's 0, 5. I don't think we have any ordered pairs we have to do. Asymptote. Stay with me, guys.
I'm here. Y equals
Yeah,
something.
Y equals.
It's still the x-axis that my graph is never crossing.
In behavior.
So it is y equals 0. Keep in mind, I agree this is the x-axis. We just have to give it a better name. Okay, in behavior, they're going to ask me two things.
Yeah.
As x approaches negative infinity, what does y approach?
Infinity.
And as x approaches positive infinity, what does y approach?
0.
First one's 0. Last one.
Infinity.
Okay, now, notice,
Remember these pens?
we have to think. Listen, my graph did flip here, didn't it?
It did.
Which affects in behavior.
Oh.
Okay, as x approaches negative infinity. So that's saying as we go to the left.
Left.
As we go left on the graph, where are my y values going?
Up.
Up, and away?
Up,
Yeah.
up and away.
So what are my y values approaching?
Infinity.
Positive infinity as you go left. As I go to the right, as x values are getting bigger, what are my y values getting closer to? They're approaching that axis, so 0.
You didn't have to use it.
Okay. I take it I'm done. Tomorrow, we've got a lot to do, so we're going to have to really move. We will talk about transformations in the section right below. And on the back side, we'll look at some exponential growth and decay and some word problems involving them. Okay?
You a snake, Mark?